Okay, so for this example, we're going to take a look at a topic called optimization. So this is a type of uh, problem that can be solved using calculus. But since we haven't developed those tools yet, but we will take a look at ways that we can solve it with the tools that we do have at our disposal right now. Right now, one of the emphasis in calculus is this idea of what's called optimization whenever we want to maximize something or minimize something, right? Much like in real life, we always have restrictions, whether it be time, right? Money, like cost of something, or material at hand, right? But we do want to use with that material or time or money, we want to use that to make the most of something, or in some cases, if we are making a product, we want to minimize the cost, right? So this is a topic of optimization. So in order to do that, right, we need to determine, right, what is our restriction, right? What is holding us back, or what do we need to optimize, and then create some kind of objective function with that restriction, right? So here's an example to kind of illustrate what I'm talking about here. So a rectangular plot of farmland will be bounded on one side by a river, right, and on the other three sides by a fence. With 800 meters of fencing available, what is the largest area you can enclose? All right, so the idea here is that we have a river here, right? And I'm going to use the fence to get a plot of land across here. Now it's up to me how I would like to do this. All right, do I want to do it like this? All right, let's assume that that's a rectangle here. So do I want to do it like this or somewhere in between? All right, where let's say that this is 100 meters, this is 600 meters, 100 meters. Mhm. So again, perimeter, right? That 800-meter goes around it. All right, so that's the perimeter here. And then here, let's see, this is, let's say 350 meters, 350 meters. And that leaves us here 50 meters. All right, so these are ways that I can use my 800 meters of fencing. Right, now in each case here, if you look here, area of the rectangle is, what is it, 60,000 meters squared. And then here, right, 35 times 50, 17,500 meters squared. Right, so you see there is a difference in the amount of area that I'm going to be able to cover, depending on which how I choose to use my fencing. So is this 60,000? Now that seems like a lot compared to 17,500 square meters. Is this the best that I can do? Okay, so the idea here is not to just kind of guess, just kind of draw different rectangles and see, all right, which one is the best one? All right, so now okay, so here, so let's first bring in, so what do we know? I know that the perimeter needs to equal to 800 meters, right? This is all the fencing that I have. I'm going to use all of it, right, in order to maximize the area, right? And I also know that in this case, my rectangle, so I'll just keep it general here. I won't give it numbers. I'll just call it length, and width. So that fourth side doesn't need any kind of fencing, right? So I know that the perimeter, when I add up all the sides, is also going to be 2L plus W. Okay. All right. So now I need to determine my objective function. Right. So my objective function is the function that I'm going to optimize. In this case, I'm looking for a maximum. All right. Now, again, going back to the problem here, let's see, all right, what are we asked to maximize in this case? So what is the largest area you can enclose, right? So here, these are optimization words, right? Whenever you see largest, the most, minimum, right? So those are optimization type words here. Okay, so my objective function is going to be the area, right? So area is length times width. But here I have it in terms of two variables. So once you've identified the objective function, it'll usually be usually be more than one variable. So the goal here is to change it to a function, right? This is not quite a function in one variable. So I'm going to now use my known information, right? So here, so I'm going to use this information here to solve for one variable, right? So if P is equal to 800, but the perimeter is also 2L plus W, then I can simply set those equal to each other. All right, and here I'll subtract 2L. So these are not like terms, so we get 800 minus 2L equals to W. Okay, so now I am going to substitute into my objective function. All right, so area, L stays L, and W I'll replace with this quantity here. Okay, so now notice here, now I have my function, my objective function, in terms of one variable. So now my goal here is to find where does this function obtain its max value. Now the max value, so here, the input here is the length, which is the length, and the output, which is the value, is the area, right? What it's equal to. Okay, so I'm asked for two things, right? I'm asked to determine what is the max area or the max value, sorry, so the output of it. At which point does this function achieve its maximum value? All right, and after that, the dimensions, find what L is, find what W is, right? L should come right away. W, we need to put a little work into our equation, right? But now let's take a look here. All right, again, if we had calculus, we would use some kind of calculus approach, but here we don't have calculus, but what we do have is we have Desmos. We'll essentially just graph it, right? Okay, all right, so now I have Desmos here, and let me plug in my equation. So it's L now. Desmos interprets the area, or excuse me, the variable to be x, so I'll just replace L with x. So we have x times 800 minus 2x. Okay, all right, so here, okay, so, okay, let me adjust the window here. Okay. Okay, so it doesn't make sense to have negative values, so here. All right. Okay, so I'm just adjusting the window so it looks So we get the gist of it, right? So again, ignore all negative values since it doesn't really make sense to have a negative length. So here, 0, x, and less than 400. So this is essentially my working domain for the function, right? So then you notice here that, again, the x variable is representing the length, right? So, so the length here, now, the shorter that the length becomes, right, the wider it becomes, right? So as I shorten this side L, then that means that I have to make it wider, right? In order to make use of that 800, because I'm always using 800 meters. So as you see here, it doesn't make sense to make it that side super short, but it also doesn't make sense at a certain point, right? It can get too large, right? And you start making, remember, all these values here on the parabola along the y-axis, those are all the area. So it makes sense to have L to be a certain length, right? This here, but at some point we get to this, right? Where L now has become too large and the area starts to become less, right? And we see that here, right? So what did we get? L was 350. So just so you could see that point here, 350, comma, 17,500. All right. Is that what I called L? 700, 800. Okay. So I think I had that backwards here. So 50. Okay. Okay. Here. Okay. Where'd you go? Okay, here we go. Oh, I see what it's. Sorry, this. I made a bit of a mistake here. Sorry, going back here. That should be 100 meters. And then this is 35,000 meters squared. My apologies. Just wondering why that didn't make sense here. So, okay, so here we have 350. And what do we say it was? 735,000. Okay, and you could see there, in choosing the length to be 350, we could see that that is not at all maximizing our area. Now, the other example we had here, if we chose it to be 100, and that gave me 60,000. Okay, now that is getting closer, right? But that is not quite the most that I can get, right? The most actually turns out to be this value right here, right? So there are two values here, right? That point there is the largest value that we see on the graph, so that is going to maximize it, right? And that point happens to be 280,000. So our max value is 80,000, right? And that is the area, right? So 80,000 meters squared, right? That's the most that I can enclose with that area of fencing. Now, the other value, 200, that's going to be the length of the rectangle, so 200 meters, which means that for our rectangle, the dimensions would be 200 200, right? And then 400 is left, right? Because the total needs to be 800 of the perimeter. So those are our dimensions of the rectangle.